Back to practice test number 2. Here we go. We are going to pick up now with problem number 2B. Here we go. We're going to write the equation of an ellipse whose vertices are 3, 2. And 3, -4. Those are vertices now. And foci are 3, -1 plus √5 and 3, -1 minus √5. So that tells me that my ellipse opens like this. Because remember, the foci are always on the major axis. So if the foci are up and down, that means the ellipse is stretched this way. Now we're writing the equation. So the equation of an ellipse has this format in standard form. Now we need to look at our stuff and figure out what we can fill into this equation. All right? So here we go. What do you think we can fill in to the equation? Anybody see anything?
36 per y.
Okay, now in order to do that, did you figure out what your center was first?
No, I just counted how long to
Okay, well you can get your center then from even that, right? Where's our center going to be? It will be at the point 3, comma, -1. So if your center is at 3, -1, we're going to have -3 plus 1. Charlie, why don't you move up here? Would you move up here? Now under the denominator, you are exactly right. Under the y has to be a what? What's going to go under the y? I don't think it's a 36. What's it going to be? A 9. How do we know there's a 9 under the y? Because we went up and down 3, right? Now, I have no idea how far sideways it goes. I have no idea what that number is. I know it's smaller than 9, but I don't know what it is.
4.
But I have my focus. So I know that the distance from the center to the focus is √5. And in an ellipse, center to focus is found by subtracting the denominators. So 9 minus something has to be √5. So 9 minus n has to be 5, and it looks like that number must be a 4. Wow is right. We really have to think about these. Now we got almost exactly the same thing, but it's a hyperbola. But the given is the same, and I think we're going to do about the same stuff. Let's see. So 2, -4, and -8, -4. Now groupies, those are the vertices. Doesn't that tell me I open this way? Which means when I write my equation, which letter will come first? X. You don't know that until you figure out which way it opens, gang. Okay? So once I plot those vertices, I can see it open sideways. All right, and I know my foci are back here too. Okay. So tell me where I go from here.
The y is 4. The y is -4.
The y of what is -4? Oh, of my center?
Yeah.
Yeah. I know for sure whatever my center is, the y coordinate is -4. Because doesn't it have to be right in line with all the rest of those things? Talking about the
Your
center
x is
now, right
-3.
here. Now, I also know that the center is gonna be the midpoint of -8 and 2, don't I? It's the average. -8 plus 2 is -6, and half of that is -3. Now, how many of you recognize you really could have gotten that from your focal points? See that? Starting at -3, going back and forth through 41. It's okay, no matter how you find it, that's it. So now I can do x plus 3, y plus 4. Now I need to fill in one of those denominators before I start doing the root 41 thing. I know I'm going left and right. When I plotted my vertices, I was going left and right how many? 5. That means under x had to be a 25? You've got to be thinking, this is like problem solving here. Going backwards.
Subtract 41 from 25.
Now, something under here is going to get added, this is an ellipse, added to 25 to get 41. Right? It's an ellipse. So what does that have to be? 16. That has to be a 16. Perfect. All right, we got one more.
A circle.
A circle. So we're going to write the equation of a circle. And the diameter has endpoints at -2, 7 and 8, 11. Okay, so here we go. We're going to write the equation of that circle. So I'm going to start with my format. Circles are easy. Remember, x squared plus y squared equals r squared. There were a couple of these on your circle review sheet, those of you that have started that homework. Hopefully you all have started it. It's due Monday. What do I need to figure out?
Midpoint.
Midpoint. The center of the circle is going to be the midpoint. So, -2 plus 8.
3.
Divided by 2 is 3. 7 and 11. Divided by 2 is 9. So Griffin said x minus 3, y minus 9. He is correct. X squared plus y squared is r squared. So I need my radius. Jack, you paying attention? Which is this. How am I, you feel okay?
Yeah, my arm, I can't like.
What happened to your arm? Do you need to go to the nurse?
No, I'm fine.
You have nerve
Okay.
damage?
Alright. Alright, let's use our distance formula and find our radius.
Dude, I did too. Doing what you want to do.
Yeah.
You just need some
Sorta.
ham. What are we working
Depends.
about?
Rectums, hams, turkeys, different type of cheeses and baguettes you can get overseas.
Yeah, I know. I don't want to interrupt you much.
No,
Get back to
freak
the
out
business.
for no one.
No one.
Good to see you, buddy. Your seat's still empty. Right up here. Alright.
That's huge.
Next year.
Someday you'll be back.
Maybe.
I will.
I will. Oh, was that busy?
I will be back in this city.
Charles.
Chuck's will be back.
Charles.
I'll say hi to you.
Charles
Be a
has been
fifth year
working.
senior. Starting 50 years.
Here we go. 8 minus 3 squared plus 11 minus 9 squared. Here we go. I'm doing my distance formula. Hopefully doing it right. So I got 25 plus 4. I got root 29. Now be careful when you write your equation. X squared plus y squared is r squared.
Why is there a more?
So this is just going to be a 29.
Why is there a fraction? $29.
No, that was a blank that I'm going to fill in with R squared. It's okay, it's alright. Alright, now we're switching gears. So we, on test day, can expect to have to write one of everything. Alright, just like we just did. Now, let's look at part 3. Classify the following.
Hyperbola.
In order to classify these guys, notice they all have XY's in them. Do not look at the picture or look at the equation. I mean, do not look at the equation and assume anything. You need to do the discriminant. Do you remember that from a couple days ago? When you do the discriminant, I'm just warning you right up front, I am sneaky. Make sure that A, whatever you plug in for A, is the x squared. Whatever you plug in for B is the xy. And whatever you plug in for C is the y squared. If one of those is missing, you fill it in with a 0. They might be out of order. Pay attention. Okay? Alright, so here we go. B squared minus 4AC. 16 minus 4 times 3 times negative 10. Right? Now, I wouldn't even waste time figuring it out. We don't care what it is. All we care about is what? Positive or negative. Now, 0 would matter, but clearly that's not going to be 0, so I'm not worried about that. Is that number going to be positive or negative? Positive. And when it's positive, we have a hyperbola. Okay? Now, here's one of the tricky ones. What's wrong with this? What's different about this? Things are out of order. B squared. Jeff, did you just hurt your arm?
No, it's just like weak.
Just all of a sudden it got weak? Has this ever happened before? Are your parents aware of it? Well, why don't you tell your parents that periodically your arm gets weak? That sounds like there's something not right. You need to go see the nurse. Are you sure? B squared minus 4. What's A? 9. What's C? 1. Oh my goodness, wait a minute. 0. What have we got here? Parabola. When the discriminant is 0, you have a parabola. Alright, here we go. B squared minus 4AC. Positive or negative? You're written on your paper, honey. Oh, you're just rewriting. So that would be a negative number. We don't really care what it is negative, but it's a negative number, which means we have an ellipse. Those problems should be gimme points on the test if you know the rules and if you're paying attention. Okay? So here's an example of a trick I might use. Look at that top equation now. What's A? 3. What's B? Negative 4. What's C? Top equation, I erased this. So what's C? 0. Remember, C is y squared, A is x squared, right? If they're not squared, put a 0 in. Okay? Alright, you stand warned. Alright, next page. Page 4, or page 3. Problem 4. Now, this little box here, this little type stuff right there, that type stuff at the top there, that's cut and pasted right off your test. Okay? So that's exactly what it looks like on the test. May not be problem number 4. but that's what it looks like.
Should I hit the 5?
So what you're gonna have to do is, like for problem number 1, the only information that's asked for in problem number 1
The center.
is eccentricity,
And then radius. Surely it's a circle.
and number 6 is center,
Oh.
and number 10 is radius. So this is the information that's gonna go in the blanks. See how that works? It's coded by number. So whatever the number on the blank is, that's the information you put in that blank. So what is number 1? Well, I'm guessing that since I asked you for the radius, it's probably a circle. Would you agree?
Yeah.
Yes.
Now, what's the eccentricity of this circle and every circle? 0. Fill that in. You don't have to know anything about center and radius. Every circle has an eccentricity of 0. Every parabola has an eccentricity of 1. The others you have to find. All right, so here we go. In order to answer these questions, we're going to need to get this thing in its standard form. So that means completing the square, right? You do not have to do any factoring though. You're just going to straight complete the square. So, what goes in this first blank here? 16. And that's exactly what goes on the other side. What goes in the second blank? 64. And that's exactly what goes on the other side. So now we have x minus 4 squared, y plus 8 squared, equal to 82. Right? Keyshawn, you with me? What's my center?
4 negative 8.
4 negative 8. What's my radius? Remember, x squared plus y squared is r squared. So what's my radius? Square root of 82, which does not reduce. So we just leave it the square root of 82. Done. That was easy. Let's try the next one. At this time, the information I'm being asked for is the eccentricity, the vertices, the latus rectum endpoints, the directrix, and the focus. My guess is then that number 2, or B, letter B, is a parabola. Does that seem like a reasonable guess? Does that look like a parabola? It sure does. We know automatically the eccentricity then is 1. You can just fill that in. That's a guaranteed point. Now, we need to do what we did over here. We need to complete the square. But since there's only one square, we only have to do it once. Put a 9 on both sides. So 1 minus 3 squared equals 10x minus 10.
Pull 10 out.
You okay with that standard form? I've done so many completing the square, sometimes I go a little quick. Everybody following that? Now this is a perfect example of how you can really mess up if you're not paying attention. Where's your vertex? 1, 3. Everybody see that? And you gotta pay attention to that because I'm not gonna be sitting there giving you hints while you're taking the test. The center is at 1, or excuse me, the vertex is at 1, 3. All right, so 1, 3. Which way do we open? Now, pause, think, don't just do something. Which way does this open? Reese?
Right?
Right. That is absolutely correct. It opens to the right. Why does it open to the right? Because it's a y squared positive. Is there a lot of stuff to remember? Yeah, can't help it, gotta do it. Here's my axis of symmetry. They didn't ask me for it, but I'm gonna go ahead and put it down there because it reminds me that my focus is gonna be moving straight right. How far is it going to be moving? Well, 4p is 10. So p is 2.5. 5 halves, 2.5. So I'm going to start right here, 1,3, and I'm going to go forward 2.5. So I will be at 3.5, 3. There's my focus, 3.5, 3. Remember, not grading the picture, just grading the blanks. So make sure you put your answers down in the blank. If I went forward, so right here, my vertex, if I went forward 2.5, then I'm going to come backward 2.5. The directrix is a line, and it will be what equation? X equals, it crosses the x-axis, I'm going horizontally here, backing up horizontally. X equals what? Negative 1.5. Now I want the end points. This question was the end points. I want the end points of my latus rectum. So that segment is going straight up and down through the focus, right? So I'm going to start here and I'm going to go up and down. Now, how far up and down am I going to go? 5. Because the whole thing is 10. So if I start at this point and go up 5, I will be at 3.5, comma 8. And if I go down 5, I'll be at 3.5, comma negative 2. All right, we're almost done. Here we go, letter C. Now, for letter C, I want the eccentricity, I need the vertex, I need the focus, I need the center, the length of the major axis, and I bet the length of the minor axis. Yep, that's what I need for this problem. So apparently it's a ellipse. Everybody have all this? All right, so here I go with my, I'm going to go ahead and start completing the square. So I'll take the 16 out of my x's, a 9 out of my y's, and I'm ready to go. Everybody caught up? What goes here?
2.
Oh, no. Half of 2 is 1, and 1 squared is 1. What goes here?
16.
What goes here? 4. But over here goes 36. So we have 16x minus 1 squared, 9y plus 2 squared, equal to, is that 144? Which happens to be 16 times 9. So we have x minus 1 squared over 9 plus y plus x squared over 16. Alright, these are the blanks we have to fill in any order that it helps us. I like to start with my center. What's my center? 1, negative 2. I need my vertices. There are going to be 4 of them. So here we go. To get the vertices, I'm going to count sideways 3. So 1, 2, negative 2, negative 2. 1, 2, 3, 4, negative 2. And then I'll go up and down 4. Everybody okay with that? How long is my major axis? Count it up and down 4, so it would be 8. And your minor axis, you went sideways 3, so it would be 6. Now we need our foci. I had to cover up that blank there. We need our foci. They're going to be here. How far is it from the center to the focus? In this ellipse right here. Alec, how far is it from the center to the focus in this ellipse?
5.
We did it again.
No,
We're
yeah.
subtracting our denominators.
Root 5.
7. 16 minus 9.
1 comma.
So we're going to go root 7. Root 7, 16 minus 9. Some of us don't get that right sometimes. So we're going to go sideways, or excuse me, up and down root 7. So if we go up and down root 7, this will be 1 comma negative 2 plus root 7 and 1 comma negative 2 minus root 7. Now when you put those in the blank, if you want to write them together, 1 comma negative 2 plus or minus root 7, that's fine. If you want to write them separately, that's fine too. The only thing left is the eccentricity. So think about our last conversation. Eccentricity for a circle is always 0, for a parabola always 1. But for the other two, we do center to focus over center to vertex. So that would be, you're right, root 7 over, watch it. How far up did we go? 4. Remember, when you find your eccentricity, it's, if you're going up to get the focus, you're going to go up to get the vertex, okay? So it's root 7 over 4. That's your eccentricity. Anybody have any question about that? All right, one more of these, then we go to our 3D stuff. So here we go, number 9, or D, problem 4D. 9y squared plus 2y minus 4x squared minus 4x, watch it please, minus equals 43 plus. There are a few places on this test where if you just really aren't on your toes, you're going to mess up. And this is one of them. When you factor that negative 4 out, make sure you change that sign. All right, so here we go. What goes here? 1, but this will be a 9. What goes here? 4. But this will be a negative 16. So we have 9, y plus 1 squared, minus 4, x minus 2 squared, equal to 36. And then we'll divide everything by 36. I'm going to answer some questions. We need the eccentricity. We need the vertices. We need the foci. We need the center. We need the asymptotes. And I'm looking at the wrong thing. 7 was asymptotes. 8 is transverse and conjugate. All right, here we go. Are you ready? Just think you're almost done. Doesn't that make you happy?
Charlie's sad.
I can tell. He's devastated. All right, where's our center?
He needs a Friday hug.
2, negative 1. So my center is 2, negative 1.
Charles?
Everybody catch that? Center's at 2, negative 1. All right, the 4 tells me to count up and down 2. And the 9 tells me to count sideways 3. And I'm going to build a box. Because this is a hyperbola. Which way do you open this guy? Up and down. So he's going to look like this. Which means these 2 big purple points here are my vertices. So 2, 1 and 2, negative 3 are my vertices. It also means that this is my transverse axis. Since I counted up and down 2, my transverse axis is 4. My conjugate axis is 6. Now my foci are going to be located here, right? I need to find the distance from the center to the focus. How do I do that in an ellipse? Or a hyperbola. How do I do that in a hyperbola?
Square root of those added together.
Yep, so it'll be the square root of 4 plus 9, so that's going to be root 13. So I'm going to start right here and go up root 13. So this will be 2 comma negative 1 plus root 13 and 2 comma negative 1 minus root 13. Remember, that's center to focus. So you're starting right here. You're starting at negative 1. So your foci are 2 comma negative 1 plus or minus root 13. Now let's stop and do our eccentricity, because we can do that now. Eccentricity is the distance from the center to the focus. You just told me. What is that? Root 13. Over the distance from the center to the vertex. What was that? How far up did I go? 2. There's your eccentricity. 313 over 2. Now, the only thing left is the asymptotes. I know they will contain the point. I know my asymptotes will contain the point 2, -1. What are their slopes? Think about building the box. When you built the box, you started right here,
2, 3.
counted up 2 and over 3. So one of them has a slope of 2/3, and one of them has a slope of -2/3. So then you write your line, however you want. I'll be quiet. You do it however it works for you. I'm a point slope person. So one of my asymptotes is y equals -2/3 x plus 1/3. That's one of my asymptotes. And the other one is y equals 2/3 x minus 7/3. Anybody have a question about that? All right, let's try to hang on for a few more minutes. We're gonna finish this sheet, okay? That's our goal. Let's be tough. We can do it. Here we go. Part 5. Totally different now. We're doing some 3-dimensional stuff here in part 5. What are the coordinates of the vector from A to B? So from A to B, what are the coordinates of that vector? -3, 9, 2. There you go. That's it. From here to here, from here to here, and here to here. Now, what is the magnitude of that vector? Remember, when we do magnitude, it's like Pythagorean theorem, just bigger. So it's going to be 9 plus 81 plus 4. So it's going to be the square root of 94, which doesn't break down or anything, so we're just done. That's it. Now we're doing midpoint. Midpoint is average. What is the average? Add them up, divide by 2. Look at the x's. 1 minus 2 is? -1 divided by 2. -0.5, -1/2. -2 and 7. 5 halves, 2.5. And 4 and 6. There you go. There's your midpoint. Now D says take 2, -1, 4 and dot it with 3, 0, 2. Dot them. How do we do a dot product?
Times and square and add them together.
Well, we multiply the x's, we multiply the y's, multiply the z's, and add them up. There's no squaring, there's no. It's x times x, y times y, z times z, add them up. So, x times x, 6, y times y,
0,
z times z.
8.
The dot product is a number. X's times x's, y's times y's, z times z, add them up, period. That's it. Now, E says take the same two vectors, but do their cross product. Now, this is the one, remember, where you get a new vector, and we cover up the top two numbers. Remember how this works? So we're going to take -1 times 2 minus 4 times 0. -2. And then we're going to cover up the middle ones. So we take 2 times 2 minus 4 times 3. 2 times 2 minus 4 times 3.
4 minus 12.
So that's -8. But do you remember anything about the middle one? Let's change it to be +8. It actually turns out to be -8, but that's the position that you change the sign on. And then 2 times 0 minus -1 times 3. 3. Perfect. All right, 2 more. Yay, 2 more. We want the parametric equations of line AB. Now, I always start with the vector form. Parametric is going to have a T in it. You're taking multiples of something. Does anybody remember from a couple days ago or yesterday, whatever day that was, what goes in these various parentheses?
Pick one of them.
Pick one of them. So one of my points, I'm going to pick A, is 1, -2, 4. Right there it is. 1, -2, 4. I'm doing points A and B. So 1, -2, 4. Put a point in that first blank. What goes in the second blank?
The distance.
The directed distance, the vector from A to B, which didn't you already figure out was -392? Didn't you already figure that out?
Oh, yeah.
So what are your parametric equations then? X equals 1 minus 3t. Y equals -2 plus 9t. And Z equals 4 plus 2t. There they are. In the first blank, or first parentheses, goes either point, A or B. In the second parentheses, the T parentheses, goes the slope of the line, which is its direction vector. And then the last one, aren't you like so happy? Find AC, or find C. All right, so here's AC. Point A is 1, -2, 4. I don't have any idea what C is. This is point C. But I want that vector to equal vector U, which has coordinates 3, 0, 2. That's what's going on. I need to find this missing point so that this vector moves this way. So I want to go from 1 to somewhere, but I have to go +3. So isn't this going to be 4? Going from 1 to 4. Isn't that 3, kids? Now, I got to go from -2 to somewhere so that the distance is 0. -2. I'm not moving. I'm going from -2 to -2. And then I got to go from 4 to something, so the distance is 2, so that is 6. If you find the coordinates of this vector, it would be 3, 0, 2. You wanted it to match vector U, and it does. Matching means it has to move in exactly the same way. Okay, Chuck? All right, good work. We got practice test 2 done. You did it.